So we continue the derivation of Cauchy's equation considering an infinitesimal control volume. We try to combine the forces in the x direction, and here we were talking about the net forces represented by sigma ij, and of course for the moment we are considering the forces that occur in the x direction. And to obtain this force, we must multiply each stress component by the surface area on which this is acting. So when we do that in the x or minus x direction, and remember that we are taking only the linear approximation using the Taylor series, and we are dropping the higher order terms. The surface forces are reduced to this quantity. We had considered the body forces in which there was gravity. This is the contribution coming out of the surface forces in the x direction. And putting it together, if I write it in this equation, that the total forces equals body forces plus surface forces in x direction, and this is the volume, and also beta, of course, I have mentioned, is the flux correction factor. Now, we note that this quantity dx into dy into dz is occurring with all the terms. So, we can divide it throughout, and therefore, it will be eliminated. Again, for the cube that is shown there, and when we combine the forces, we obtain this form, and this is in the x direction. In the same type of exercise, in a likewise manner, we can obtain the same type of force. There will be symmetric contribution, of course, with appropriate changes. The velocity in the x direction, the velocity component is u, so u is occurring here. In the y direction, there will be the velocity component v, and in the z direction, it will be w, and therefore with respect. So all these are the three components of the infinitesimal volume that we are considering. When we sum them up, we obtain this equation. And this is what you will recall, that is the Cauchy's equation, that which we calculate earlier by using divergence theorem, and this time we have arrived at by considering infinitesimal volume of the fluid and also balancing the forces that are acting on it. That is, sum of F is equal to the summation of the momentum part.